right. So, last class, we left off talking about imaginary and complex numbers. So just to review, a complex number written in standard form is a plus bi, where a and b are both real numbers. So a is the blank part, it's the real part, very good. So that's the real part. bi is the imaginary part. All right, so what we're going to focus our attention on today is learning how to perform operations with complex numbers. Okay, so the ones that we'll focus our attention on today are addition, subtraction, and multiplication. All right, hopefully you'll have a fair amount of time at the end of class to practice today. This shouldn't take that long. I'm going to do some, and then I'm going to have you try some on your own. I'll have you put them up on the board, and that'll pretty much take us through class today. Fair enough? Okay, so number one says write each expression as a complex number in standard form. So if you notice here, what we have are two complex numbers that we're adding together. All right. And basically what we're going to do here is what we did when we were adding and subtracting polynomials. All right. Really what we did is we just combined like terms. All right. And in this case, the like terms will be the real part of the complex number and the imaginary part of the complex number. So we'll combine the real parts and we'll combine the imaginary parts. Good to go? So on this first one here, what are the real parts for these two complex numbers?
8 and 5.
8 and 5. And what's the operation that's being performed here?
Addition.
All right, so what's the sum of 8 and 5?
13.
It's a good start today, folks. All right, there we go. So 13. Then we have negative I and positive 4i. So again, I kind of would treat that if that were like a negative x and a positive 4x. We're just collecting all the x's. Here we're just collecting all the i's, the imaginary units. So how many imaginary units would we have here?
Plus 3i.
Plus 3i, very good. Now again, our final answer, we'll just take a look at that. Is that written in standard form? Yeah, we have the real part followed by the imaginary part. So if you have the imaginary part first followed by the real part, just flip those and make sure that your answer is represented in standard form. All aboard, yes or no?
Yes.
Okay. Let's take a look at part B then. I would say just be careful when you're subtracting imaginary numbers, because here this negative is going to be applied to both the real and the imaginary part. So some people like to immediately just distribute like a -1 to both of those terms and then rewrite this expression as a sum. So this would be 7 minus, actually it wouldn't be a sum, but rewrite the expression. Are we clear on that right there, yes or no? Okay. And again, now you're kind of just back to what you did in the previous problem, which is combining like terms. So what terms can we combine here?
7 and negative 3.
All right, and what's the result there?
10.
4.
Be 4. Okay. And then negative 6i and positive 6i
Nothing.
would be 0. So technically we could leave the answer as 4. If we want to write the answer as a complex number, 4 is a complex number. So I would accept it like that. You could theoretically write it as 4 plus 0i if you wanted to, but I wouldn't expect that you would do that in the future. So 4 is perfect because 4 is a complex number. Any questions there so far? Okay, let's take a look at part C. So here you have a real number, and then you have a complex number in between, and then an imaginary number at the end. Okay? So, again, I'd probably start this one pretty much the same way that I started part B, and that is I would distribute this negative through the parentheses. So I rewrite this expression as 10 minus 6 minus 7i plus 4i. And again, this problem looks very similar to the first two that we've done so far. We combine like terms. 10 minus 6 is?
4.
And then negative 7i plus 4i.
Negative 3.
Negative 3i, very good. And don't forget the i. All right, so what questions do you have before I have you try a few on your own? All good so far? All right, so I'm going to give you probably like 3 to 5 minutes here to complete A, B, and C. And what I'd like is for you to write the answers up on the board. Okay, so we are back. Spare, would you explain what you did here, please?
So I combine like terms, so 12 plus negative 8 is 4, and negative 11i plus 3i is 8.
Right, 12 plus negative 8, adding the real parts together gives us 4. Negative 11i plus 3i, negative 8i, perfect. B?
Okay, so I combined the like terms, and 15 minus 24 is negative 9, and then negative 9i minus negative 3i is negative 6.
Any questions here? The most common errors that we're going to run into with these, just arithmetic mistakes and also sign errors. All right, so just make sure that you're double checking your arithmetic, double checking the signs of your final answers. Because like I said, most likely if you make a mistake here, that one of those two things is going to be the issue. Last one?
I distributed the negative sign into the parentheses to get 35 minus 13 minus 4i plus I, which came out to 22 minus 3i.
What do we think? So again, I think most of you are familiar with adding and subtracting polynomials. You feel pretty confident with that. This is kind of a similar skill, a little bit different obviously because you have imaginary units involved, but pretty much the same idea, same premise. Any questions before we move on? Okay, let's move on to the next page. And since SATs are tomorrow,
Yeah, are we in a different room?
since SATs are tomorrow,
Right here, but take these.
We don't come to school, do you?
I'm going to give you this SAT question to try. So right now, again, I'm going to give you about, 3 minutes or so, and try to answer question D here. All right, so this question actually brings up a pretty interesting idea, and it's something that I think we might have talked about last class, but I don't remember. So the question says, which of the following complex numbers is equal to this expression here for when I is equal to the square root of negative 1? And we know that that's how I is defined anyways. All right, so what was the answer to this? What do you guys think?
D.
D, should have been D. All right, and we'll go through this just to make sure that everybody's on the same page here. How did you start this problem, or how did you start off with this problem? Go ahead.
You combine like terms, so first I distributed the minus sign,
Okay.
and then
Did you get that?
yeah,
Okay.
and then I added the like terms, which was 12i plus 6i, which
Okay.
got positive 18i, and then I automatically did the answer.
All right, so this was 5 plus 18i minus 9i squared. All right. What next?
Gotta make the 9i squared into a real number.
Okay. What would I squared be equal to?
Negative 1.
Negative 1. And for those of you who don't remember this from last time, I is equal to the square root of negative 1, correct? So if you were to square both sides, left-hand side is I squared. What's the right-hand side? Negative 1. So anytime we see an I squared, we can always replace that with negative 1. All aboard with that? And you could have done that in the initial step up here if you wanted to as well. All right, you don't have to wait until this part of the process. All right? But it has to be I squared that we're replacing with negative 1, not just I. Okay? So, let's do that. And negative 9 times negative 1 is?
9.
Positive 9. Add that to 5, we get 14. And that's where the 14 plus 18i comes from. All right, so what questions do you have about that? Like I said, when I went around, most of you had that, or at least on the way. I think what a lot of people, or what happened was a lot of people got stuck here. But in the future, when you see I squared, remember what are we going to replace it with?
-1.
-1, very good. And again, this is why we would replace I squared with -1. This is the rationale behind
I know I
that.
heard.
Okay? All right, how we doing?
We're
Okay, so we're going to talk about multiplication using the distributive property. I'm going to erase this and move this up a little bit further right now. So again, I'm good to erase this. All right, let me get rid of that real quick. Move this up. Eventually, here we go. All right, so the thing that we just talked about, replacing I squared with -1, is going to come in handy with these problems right here. All right, so don't forget about that. So this says write each, or number 1 reads, write each expression as a complex number in standard form. So what property are we going to have to apply here in order to simplify the problem in part A? Distributive property. So we'll do that. So it's 4i times -6. What do we get when we multiply 4i times -6?
-24i.
That's correct, -24i. And then 4i times positive I?
4i squared.
Yeah, 4i squared. So can we reduce -24i any further?
No.
No, because typically we don't write the negative square root of 1 in for I, we leave it as I. But what about 4i squared? Can that be simplified any further?
Yes.
Yeah, what would that become?
-4.
-4. So this is -24i minus 4. And if you remember from I don't know if it was the previous example or the one before that, I had mentioned that if you've had the real part written second and the imaginary part written first, you want to change those so we can have the complex number written in standard form. So the real part should go first, which is -4. The imaginary part should go second. And that would give us our final answer.
easy.
I agree. I'm glad that you feel that way. It's good. Now part B, a little bit more challenging because we're multiplying, expressions that contain 2 terms together. So there's, I don't want to say there's 2 different ways to approach it because it's really the same approach, just one is a more visual version of the approach. You could continue to use the distributive property as we do, or you could use an area diagram here. So I just want to run through and show you that and see if that's something that you would like. It's something that you learned in geometry. It's something that we worked with, again, way back in the polynomial functions unit. But we'll talk about it again right now. Good to go? All right, so if you think about a rectangle is a 2-dimensional figure. It has length and it has width, correct? And it also has an area, all right? So this region that's bound by the sides of the rectangle has an area. And how do you calculate the area of a rectangle? Yeah, length times the width, very good. So in this case, what we can do is we can think about each of those expressions, 9 minus 2i and -4 plus 7i. We can think of those 2 expressions as the dimensions of a rectangle. Clear on that? So what I'm going to do is I'm going to write 9 and minus 2i down here, and then -4 and 7i up on the top. So the length of the rectangle is 9 minus 2i. The width is -4 plus 7i. All aboard? Now, one thing that you're probably noticing here is that, again, this is a real number, this is an imaginary number. So those 2 have different, I would say, they have different lengths. We clear on that? So what happens is these dimensions or these lengths break the length up into 2 strips. So we clear on that? So this bottom strip has length -2i. This top strip has length positive 9. Good there? And then we can do the same thing for the width. We can break the width up into 2 strips. Again, this first strip has width -4. The second strip has width 7i. All good? So what that's done for us is it's broken up the rectangle into 4 smaller regions. and we can find the area of each of those regions. So what are the dimensions of the rectangle in the upper left-hand corner of our area diagram?
Negative 36.
Right, so the dimensions are 9 by negative 4, so the area of that would be negative 36. What are the dimensions of the upper right-hand rectangle?
9 and 7i.
Right, 9 and 7i, so if we multiply those together to get the area of the region, we get
63i.
63i, very good. Bottom left,
8i.
and the way that we get that area is that this dimension here is negative 4. The dimension of this rectangle is negative 2i. So multiply those together, we get positive 8i. And then the bottom right-hand corner, what's the dimensions of that rectangle?
Negative 14i squared.
Okay, well that would be the area. What are the dimensions? How did you get negative 14i squared?
7i times by negative 2i.
Right, so 7i would be the width, negative 2i would be the length. Clear there? Now to find the area of the region, we're just going to combine like terms. Now the first thing I'd probably do here, negative 14i squared, what is that going to become?
14.
Positive 14 because I squared is negative 1, so that's positive 14. And now we can start combining our terms. Negative 36 and 14, what do we get?
Negative 22.
Negative 22, 8i, and 63i.
71i.
Right, positive 71i. Now, like I mentioned before, you don't necessarily have to use this approach. I just know some people favor that because it gives you a visual interpretation of what's going on. But you're going to get the exact same results if you just distribute. So if you distribute 9 to negative 4, you get negative 36, which is the area of the upper left-hand rectangle. So it's the same result. 9 times 7i is positive 63i, which again is the same as the top right-hand corner, or the area of the top right-hand corner. Negative 2i times negative 4i is positive 8i, which again gives us the area of the bottom left-hand corner, or the bottom left-hand rectangle. And then finally, negative 2i times positive 7i gives you negative 14i squared, which again matches up with the bottom right-hand corner. And you would go through and combine like terms just like we did with the area diagram. Any issues, any questions or concerns there? So like I said, this gives you an approach. If you like that, roll with it. Otherwise, you can just rely on the distributive property. I tend to use this just because it involves less writing. But again, if you like that visual interpretation, then I would do that. What questions do you have before I have you try a couple of examples on your own?
No.
Okay, none? Anybody else? Yeah?
When you have like an imaginary square root in this instance, or in every case, would you just flip the sign,
Mm-hmm.
basically?
Yeah. Well, you get rid of the I squared,
Right.
and that gets replaced with negative 1, but yeah, that's going to change the sign, give you the opposite sign, yep. Anything else? Okay, I'm going to give you 3 minutes to do A and B. Get going. Okay, so we're back. Cooper,
Yep.
how'd it go? Tell me what you did here.
Just did that. Well, and knew that I squared is negative 1.
All right, so what's the process that you went through?
Distributive.
You distributed, right? So negative 5i times 8 is negative 40i. Negative 5i times negative 9 is
Positive 45i is I squared, yes.
right, and I like how you flipped these and wrote that in standard form. So the I squared, the 45 times I squared is 45 times negative 1. So negative 45 minus 40i, we all good with that?
Yep.
Okay. Tell us what you did, please.
I distributed, and then I ended up with negative 32 plus 56i plus 8i. And then I got negative 14i squared, which I knew that was supposed to be negative 1, so I just changed the sign to plus 14.
Mm-hmm.
And then I just finished the equation by solving, and I got negative 18 plus 64i.
Okay, so the only thing I would say is right here, you don't have to write like this square root. I wouldn't put that in there. This is just gonna become -1, and you would multiply -14 times -1 to get +14. All good?
Yep.
Okay. So in a few minutes, we're going to do some practice. We're just gonna do a quick little wrap up down here. Okay, so this is on the next page of your packet. What is I equal to? How's that defined?
-1.
Not -1,
Square root of negative.
square root of negative. Okay.
Just the next one.
I squared would be,
-1.
very good, negative. What about I cubed? Before you shout out an answer, let's think about this. I cubed
-1.
is equal to I squared times I, correct? We all
Yes.
agree with that, using the rules of exponents? Well, what's I squared equivalent to?
Square root of negative.
-1
It's -1. And then I, again, we just,
is the square root
Leaves
of
I.
-1.
so I cubed is actually
1.
-I. Okay, so I cubed would be -I. What about I to the 4th?
1.
Right, it's I squared times I squared. I squared is equal to -1. So -1 times -1 would be +1. Any questions there? All good?
Yep.
Standard form of a complex number is
8
A.
A plus BI, very good. To add or subtract complex numbers, combine what? Like terms, and if we want to get very specific here, combine the real parts with the real parts, and the imaginary parts with the imaginary parts. Okay, so real parts with real parts, imaginary parts with imaginary parts. And to multiply complex numbers, use what property?
distributed.
Yeah, the distributive property. And more than likely, you're also going to have to do a little bit of adding and subtracting complex numbers as well as part of that process. All right, so before I send you off to do some practice, what questions or concerns do you have? Okay, seems like this went pretty well today. Seems like you all have a pretty good handle on this, which is good. All right, but again, I think a little bit of additional practice would be helpful. So we're all set, ready to move on? Okay.